The effects of various operational parameters on a catalyst's lifetime and performance must be evaluated prior to incorporating it into large-scale installations. Various industries such as waste plastic recycling, energy, and biomass feedstock seek analytical techniques that can rapidly characterize catalyst performance and efficiency. Frontier Laboratories developed a tandem micro-reactor for rapid and accurate evaluation of various catalysts. A tandem micro-reactor consists of a pyrolysis furnace, first reactor, and a catalyst reactor containing a catalyst, second reactor. The two reactors are individually temperature controlled. As a feedstock reformation, the first reactor pyrolyzes gases, liquids, or solids such as plastics or biomass to generate gaseous products. Volatiles released from the heated or thermally decomposed sample flow into the reaction tube in the second reactor via carrier gas flow, where they react with the catalyst. If needed, a reaction gas can be added to the sample flow into the catalyst reactor. The final reaction products flow into the GC for analysis. The catalyst is evaluated by noting the compounds formed and their relative distribution using MS detection. To demonstrate tandem microreactor modes of operation, the catalyst conversion of ethanol to ethylene is first shown using real-time monitoring as an example. Helium carrier gas is bubbled through ethanol solution for sampling. Ethanol vapors in the carrier gas continuously flow through the first reactor and are preheated. A short deactivated EGA tube is placed into the GC oven. A quartz insert tube packed with the catalyst is loaded into the second furnace. The first reactor is held at 100 degrees Celsius. The second reactor is programmed to heat from 100 to 450 degrees Celsius at 20 Celsius per minute. During this period, product gases are directly detected by a mass detector in real time. Reaction products are detected by an MS detector and displayed on the screen in real time. Catalyst reaction products were monitored as the reaction temperature was raised at a constant rate. The amount of ethanol sharply dropped when the temperature reached 280 degrees Celsius, while the amount of diethanol ether increased. Finally, above 300 degrees, ethylene, the desired product, was produced. Water was also observed. To further evaluate the catalytic conversion of ethanol to ethylene, the stepwise temperature mode of operation is now used. Stepwise mode of operation is a separation analysis, so the separation column is now placed into the GC oven. The volatiles released from each temperature step are introduced and analyzed in the separate column. First reactor temperature is set to 100 degrees Celsius. The second reactor is heated stepwise, 100, 250, 300, and 400 degrees Celsius. The results of measurements made at 4 different temperatures are then obtained. Chromatograms and plots for 4 different species clearly indicate how each one increases or decreases as the temperature increases. Next example is the conversion of Ja Trapa press cake to BTEX using the isothermal temperature mode of operation. This mode is a separation analysis, so the separation column is placed into the GC oven. A powdered sample is placed in an inert sample cup. First and second reactors are heated to 550 degrees Celsius. The sample cup is loaded into the first reactor and stays at the standby position. Cryo-trapping using liquid nitrogen is turned on. The sample cup is then dropped into the first reactor and is heated. The sample is pyrolyzed in the first reactor, and the pyrolyzates are generated. The pyrolyzates flow to the second reactor and undergo a catalytic reaction. The reaction products flow into the GC. The reaction products are trapped at the head of the separation column by microjet cryotrap. Cryotrapping is turned off and the reaction products stream into the separation column. Compounds separated are eluted to the mass spectrometer and detected, and the results are displayed on the screen. Simply connect with us to learn more about rapid catalyst evaluation and how it can apply to your analytical research.